Okay, so thank you so much for attending. So we are good to go. We're gonna hopefully walk you guys through this whole journey that we went through this. Ken hates me now after this whole research. It's like a marriage, 4 months together. I don't wanna see that guy after this. He doesn't wanna see me anymore, so, but we'll see. After this whole thing, we might wanna try to recover the friendship that is really broken at this point, but anyways. Okay, so let me plug this guy. Okay. Let me know when you get the video. Okay, great. Okay, guys, so let's get started, okay? Who we are, anyways, that doesn't matter at all. With all the rock stars here, this doesn't matter at all. Okay, so the agenda, guys, we're gonna be taking you guys into the journey of all these things, what it takes us, what we did, how we were able to play with the malware. At the beginning, we said, okay, we have an infotainment, what is inside, how it's running, what are the components, how they communicate each other, if it is possible to install a malware. People talk about ransomware, those things. Is that possible? That was our initiative thought, and that's why we take this guy, okay? So what we started was, we started with the famous, OBD2 port, that is just a specific interface that you connect to your car. We use a specific one, which is car loop, that uses a specific microcontroller. That microcontroller allows us to flash the socket CAN serial firmware into that OBD2. That way we can communicate to the car and start doing basic stuff. It comes with an SDK, so it's pretty cool. You can just create your own development, flash it into your car loop, which has Wi-Fi communication, and that was our initial starting. Oh, the typical case, right? You just go and sniff the network. That's something that you guys already know. Many people talk about that. That's the reason we didn't want to focus too much on the CAN thing, car related. So, but anyways, that was our initial thought, right? So we get this guy, we sniff it, you put this guy in the OBD2, you start opening doors, closing, turn on the lights, everything is sniffing into it, and then you just take this, analyze it, and you realize what is the commands. It's nothing fancy at all. But anyways, we follow that thing, and then, let me see that place, yeah. So here what we are doing is just, we connect the OBD2, we identify specific information to turn on the lights, we just plug it in, replay it, and then we got the flashes, right? So that kind of hooked us into this thing. We said, this might be something interesting to do, right? Like, what is inside that controls this whole thing? That was our initial motivation, right? But at this point, we said, let's not focus on the car. What if we don't focus on the driver, right? So everyone talks about the car, how you can control the car. It's fine. There is great research, actually, as you know, a lot of research, great research from those guys. But we said, what if we target the driver? Why the driver? Because we said 99% of the time, as you guys know, since 8 years or more ago, we can plug our phone into the car while we are driving, right? We can pair it to the car. It's very convenient, right? I do it, everyone do it. We can speak through the speakers of the car. Plus, we don't get a ticket from the police, right? Because they will see you talking with your phone. It's pretty convenient, it's pretty cool. But what if we use that phone in order to interact with the car through the SMS messages by sending a message, talking to the RAT installed inside, and also the RAT send us back something out, and we can control it that way. And obviously without the driver noticing, right? We come up with a couple of scenarios that obviously is up to your imagination. The first one is espionage, right? So let's say that you target one guy, the Congress guy, a congressman, and you said, okay, guys, here is the MP3 music for you, whatever, social engineering. He pick up that USB, he plug it in his car. At that moment, he gets infected. And that moment, you are gonna be monitoring all the SMS messages, call. The girls, if you wanna monitor your husband messages, that's huge, right? But this might be the way, okay? Distracted driving. Distracted driving is another case where the guy, you are not allowed to touch the screen in the car because they don't want the manufacturer that you get distracted, right? But what happens if since we control the car, we can flash it, we can turn off the display, or we can reboot it, many things that distract the guy, turn on the volume so that they can distract and get a crash, right? Monetization, obviously, since we control the SMS messages, we can send it out to premium services. That's the traditional malware does. Ransomware, right? Everyone talks about ransomware. We have a kind of wiper scenario here at the end where we basically just put this guy without booting anymore so that you can take it to the dealership because it won't connect anymore, okay? And finally, spreading, obviously, you take the access list of all the guys in the phone. You can spread malicious links, all of them. You have that information ready. So let's go quickly to what we did at the beginning. So we said, okay, we're interested in this guy. So we need a test bench. So we need something to play with it, right? We don't want to play with a car at that moment. So we said, let's take the same thing. So we go and we need to find a car infotainment, find the wiring diagram, mandatory to find it. Find someone who can understand the wiring diagram for you if you don't know it, which is our case. Alan Mont, great guy from Carloop, he helped us a lot. Pray that works because you might want to get that infotainment and probably it doesn't work. You're getting it from eBay, something like that. Make sure to ask for the pigtails. Anyone knows what is a pigtail here? Okay, you will know, okay? So pigtail is mandatory. Are those cables that you see behind? If you don't ask for the pigtails, there is no way for you to connect this guy. So that was actually my recommendation because when I was about to buy it, my friend says, hey, do you ask for the pigtails? I said, what is that, right? So then eventually they gave me the pigtails. We were able to put it up. So here is the guy that you are seeing, the front and the back end. Those are the famous pigtails. Now you know. You can tell your wife at night. So now this is how it looks like that guy in the car, okay? So that you have an idea. Okay, so the motherboard quickly has a Linux 32 bits ARM v7 EMX6Q, which is free scale, you know, NXP right now. It has some memory there, touchscreen, Bluetooth, JTAG for the Bluetooth, Renesas microcontroller, 16 bits, M16C that controls all the CAN messaging. You have these specific pins that allows you to talk to that microcontroller. We failed miserably in that. We tried too hard. We never get it working anyways. GPS, backup camera, and USB Ethernet. That USB that you are supposed to plug in your iPod turns out to be Ethernet, which means you can plug in, get TCP, and this guy has SSH enabled, so you can just connect to it, right? It's pretty easy. One of the options that Gerardo is going to explain later. Okay, we got the wiring diagram. It was flash-based. For those that you know about wiring diagrams back in the day, were those, you know, very hard to follow, and you have many papers, those things. So this was flash-enabled, pretty nice. We found a leak in internet, lucky for us, but at the end of the day, we use it in order to start building this guy. So here is the first schematic of this guy. There are multiple components in this specific infotainment. I mean, it's just huge, the components that we saw there, and we just were, you know what, we need to focus on something, otherwise we won't do anything. So we focus on the audio system. The audio system is the connectivity master unit. This guy, when you see the screen, the GPS, the audio, radio, that's the connectivity master unit. That connects to the CD-ROM, which is at the top. It connects with other components. So that guy has this specific component. This specific connector, which is 920, that is the one that we all need in order to put this guy up, nothing else. Okay, so this is the back of the infotainment. Here is the connector that I told you, 201. That's the one that we are seeing in the screen. This is how it looks now in our infotainment after wiring it. And then just a couple of things here important. That guy has CAN, it's a CAN gateway. We didn't play with CAN because our case was not even needed. You will see why. But it has CAN high, CAN low. You can plug in it, play it with that. You have the accessory. Anyone knows what is the accessory? Yes, my friend. Thank you. Okay, so the accessory is another thing that I learned. When you go to your car, right, and you push the button of start button, that's the first one, right? So this place goes off, goes on. That's the accessory. Then when you push the second one, that's the ignition. The car starts. The same with the key. The first time is the accessory. Second time, you put the ignition up. So the accessory is very important because that one, if you don't connect it to the voltage, it will never, this guy turn on. It's like putting the switch button into this guy in order to boot up, right? Something very important that we learned during this thing. Okay, connecting the DOS, we connect this guy up, and we have it up and running, as you can see it here, okay? Breaking into infotainment. So now, Gerardo is going to talk about what we did in order to go through this phase.
Okay, thank you. Can you hear me? Yeah, I think so. So once we had our rig set up and ready for us to start hacking into it, we started thinking about what different ways we could gain that access, that initial foothold, right? So at the beginning, we had this very first thought. We know there is a USB port there, so let's see if we connect to that one, and we can see some network services running there. So it happened, like we run some port scan, and we realized that there was an SSH port running there. So okay, we thought maybe they are using weak passwords. Let's try some brute force attack on it, some dictionary attack. And yeah, happily, after a few attempts, we got root access through SSH. So we were very happy at that time because it didn't take much time to get us the initial access. So, but we kept exploring other venues. And soon we realized that last year, Jay Torla made popular this very well vulnerability that is a common injection in one of the components in the infotainment system that I will explain a little bit more about this. And this was also very nice because it's working. It's affecting firmwares earlier than version 55. That's exactly what we have here. And it was patched until version 59. So during that new version 59, actually the vendor did a very good job at improving the security of the system by disabling SSH authentication with password. Instead, now they are using certificates. They have some other things there that we also tried and didn't work out. The cool thing about this vulnerability is that it's existing out there in thousands of cars. Why? Because this vulnerability is not updated automatically. There's no over-the-air update to patch this. It has to be done willingly by the driver going to the dealership and asking for an update. So who does this? Like, really nobody. So it was a good way for us to start creating this potential malware, right? So also this gave us the very first stage for the attack. Why? Because we had with this vulnerability our infection stage. Because through some social engineering, we could just give a USB flash to someone with running this car and make it plug it in and get infected. Okay, a little bit about the vulnerability that Jay Turla made popular. It's just this service running in the infotainment that is polling for events on the USB. Once it detects there is a new memory connected, it will search for a very specific file name within the file system called JCI auto update. If this file is found, then it will try to find another file, a zip file, that it will copy and extract some other files. Within that file, it will try to find an ini file that contains some kind of pseudo language instructing how to proceed with the update. In this initial ini file, it will instruct to go and search for a second file, also an ini file, that again it will instruct to copy 2 more files, unzip it, and run a bash file. Within that bash file, there are a couple instructions. The main one is instructing the infotainment to run this internal component, data retrieval. That's part of the updating mechanism. And this component takes as input file argument. But the problem here is that when this file, the next file that looks for, and it parses, there is this keyword command line. The value of this key is parsed and using a system call without any previous sanitization. So we have the command injection vulnerability that allows to run whatever we want with root privileges. Okay, so now we have ready the very first stage of the malware, right? We can infect a victim. Now, for sure, we want to persist across reboots, right? We achieve our initial attack, but we don't want to have to force the user to infect the car every time he boots up, right? So we have to find a way to do some persistence on the system. Luckily for us, we find something very similar to what we see in Windows with the service control manager. We have a service manager that is responsible for launching all those binaries and services that are needed for the correct working of the system. And this is done also through a very similar mechanism as in Windows. There is this registry-like file called sm.conf. It's just an XML file that will parse and use to find the paths for those binaries that it needs to launch and with which arguments it needs to pass. Before achieving the real persistent on the infotainment system by infecting this registry file, there is a previous step that we have to achieve, and that's remounting the file system of the infotainment as read-write. Why? Because by default it's read-only. But this is easily achieved because it's only a Linux system, so just a matter of doing a mount. So here's just a small sample of how that XML looks like after being infected. It's just a line, something simple. So we have a small demo about how it works.
So what we're doing there is that we're going to connect the USB into the car port. We plug it in, and then that is going to transfer the malware into the infotainment. This is something that you can do, obviously, by doing social engineering, as I said. And we count the time. The whole process that Gerardo explains takes around 30 to 45 seconds to complete. But eventually, when it completes, what we did is we just pop up an easy message just to show that it is inside. Obviously, in a real scenario, you won't pop up anything, right? You just get installed, get persistence, and start communicating with the guy, as we are going to show in a few seconds. So here, basically, just sending that. We are waiting there just for this message to pop up to say, hey, I got the infection done. But as I said, it took us like around 40 seconds for this thing to come up. But it's coming in 5 seconds, I guess. So you see there, that's the message that says, okay, so Salinas RAT is installed and is infected the system, and that was the first whole thing that Gerardo just explained.
Okay, so now let's move on and see all the different components that are within the system.
So now, once we get into the infotainment, we start understanding how it works, right? Well, that was our first initial goal. So we realized that this guy that you are seeing in, we'll see you on screen, not yet. That guy is running Opera, JavaScript, connected to a local server, web server, and that is just like a animation done to the infotainment. Anytime you touch a screen that display, that sends communication via WebSockets through JavaScript to a main component that is called the multimedia system. This multimedia system is just the proxy. If you want to, for example, talk to the radio, this guy is going to say, I need radio communication. He's going to load the radio library, and it's going to do whatever it's supposed to do. If you're going to go to a Bluetooth pairing, this is the interface that eventually it will connect with all those different interfaces in the whole car. Okay? This guy is also started, as Gerardo says, with the service manager. But there are other many components that we basically touch a little bit. It's too much, so we just focus on this specific goal. But there is the beam, for example. The beam is just a way to interface with the car so that you can, via GPIO, you can check the ignition status. This specific brand has the parking lot in a button. It's not physical. So this has a parking brake switch to know if it is enabled or not. It's read-only, though. Very important to mention that all those different sensitive actions turns out to be read-only, which means we cannot control it through software. Some of them we can control, like Watchdog, which was very useful for us because when we were trying to do remote debugging, as Ken is going to explain, it was killing our process of it all the time. So it was one of the ways that help us to understand more the system. LVDS is more into the video-related stuff, brightness of the display, sleep mode, the messaging, which is very important one. That messaging is the one that Ken use a lot in order to interact with the malware. And finally, the VVS, which is all related to the CD, DVD, the body control module of the car, the settings of the car. Like if you want to go to the dealer for maintenance in the next month, you need to set up a threshold. That's the kind of things that this module control. But it's just like a brief overview of this whole thing going on inside. Okay, and that once we were inside, we found something that is very common if you guys have been doing, of course, you have been doing firmware analysis. So these guys, manufacturer left testing tools. Those testing tools were great for us because we don't need to understand too much of the information. We can just use it and skip to other stuff instead of start reversing all of them. One of the things that we found here, for example, is that how we can connect and disconnect the phone, which is something that we really use in our attack that you will see later. But we don't need to reverse that component, right? We just need to use that tool that they left. We reverse the tool to understand how it works, and then make it work for our benefit, and then spend more time on the other things that we don't need to spend time, right? So the tool is very simple. It's a client-server application left in the firmware. It takes all the commands through an XML file. It communicates through message queue. It's like an IPC mechanism where you can read and write through it. That talks to the test observer. The test observer is, again, as a proxy. It has multiple plugins ready for us to understand. No symbols removed, strip, everything there for us, pretty easy. It has audio, for example, Bluetooth configuration. All those informations allow this manufacturer to test the car, like test the audio testing, test the volume, set it, get it, Bluetooth, pairing, unpairing, making phones, incoming calls, outgoing calls, all those different testing going on, configuration of the car, what is the build date. You can even change the build date of the car so that your car might be 2018, you might get $2,000 more, maybe. So phone testing, clear DOMs. You have a lot of core DOMs going on in the info system. These guys use this tool to clear all the logs, all those things. Wi-Fi. This guy has Wi-Fi, has an access point which is not enabled, but obviously it can be enabled. That can be used to scan other networks. You can change the SSID, change the password, all those things here. And they can, obviously. They have a specific tool to test scan that we said, thank you so much. We don't need to learn how you interact with that. And that's one of the things that we leverage in our effort that you're going to see later. This is just a quick example of the commands being executed. That's you need to execute a prefix, and that prefix has a specific set of IDs that ties a specific guy. Like ID number 1 is audio, ID number 2 is Bluetooth, you know, that kind of things, and that allows them to interact. We are going to show you that in a second. After that, it was like, I remember well, it was probably 2 months ago at 3 a.m. in the morning, and then we were saying, okay, so let's try to debug this service, whatever, right? And then we said, you know, it's not stopping the breakpoint for some reason. Ken is going to explain you why. But anyways, we said, let's remove this specific service from the infotainment, right? Just to make sure that it's not breaking into it because probably it's not going through it. I mean, we just remove it. After that, this guy stopped rebooting. No more USB access, no more Ethernet access, no more Wi-Fi access. We are like a 2 weeks away from the call for papers, and then this guy is not booting anymore. We don't have a way to recover it. So we were so frustrated. Ken, I remember he was crying for 2 hours. I didn't want to say that, but it's true, my friends. So I need to share with you guys the whole journey, right? So after that, I found this blog in internet. One guy that kudos to those guys. There is a lot of community related to this kind of cars. Of course, we focus on something that is not there. That's the value. But we found this guy saying, hey, we got this information. There is a UART access. You just need to plug in this to our XTX. So we just connect our bus parade. We were back online, happy, and coming up with the full effort. Finally, this was our full setup in the whole thing. A bus parade to get UART console access. In case something happens, we always have recovery options. Black that we use it to compile the RAT because it has ARM v7, exactly the same version. And we use this bus USB port hub that we use so that we all have Ethernet access because when doing remote debugging was kind of slow through Wi-Fi. So with this, we have a spread Ethernet for all of us in the table so we can debug it faster. Now, let's talk about the next step.
All right, thank you, Daniel. And just for record, I didn't cry. All right, so debugging the binaries running on the infotainment, unfortunately, is not that straightforward. Really, there are 2 major challenges in here. The first one is the watchdog, and the second one is the issue with the GDB server we have. If you just attach to any running process on the infotainment, the watchdog is going to kick in and then reboot the entire system, and that's really annoying. So one way to bypass that is to kill the main server's monitor process, which is responsible for setting up all the watchdog and then making sure it's active at all time. So killing it effectively means it's dead, and then so there's no more watchdog, and then you can just debug like you normally would. And later, then you'll find out that you can also disable the watchdog through GPIO by setting the value 1 to this value file here. But unfortunately, that's still not it. We still have to figure out like what's wrong with our GDB server. So the issue is that we cannot set a breakpoint to any of the library functions. So if it's just like a straightforward ELF binary, it works just fine. But if you're trying to insert a breakpoint outside the memory address of the binary you attach to, there's some issues with that. So the workaround is to set an instruction breakpoint by using the undefined instruction. So first, you locate a function itself of interest by looking into a process memory map file. And then once you locate it, you patch it with undefined instruction. And later, you just resume the execution. And once the program hits the undefined instruction, it's going to raise a SIG trap. By leveraging that trap mechanism, you can regain the control of the execution. Then that's when you patch the bytes back to the original bytes. And then from there, you can debug like you usually would do. That's the SIG trap. So now we have the whole test bed environment set up, and then we are ready to debug. It's time to get our hands dirty and do some reverse engineering. And then so in this section, I'm going to tell you a high-level execution flow of the messaging system, and then all things that can be done to make a RAT, and then all kinds of wrong we have done to figure out what's the better way to do it. So here is a simplified diagram for the flow of the messaging system. It's pretty much similar to the one we presented a couple slides back. It just like kind of abstract a few details away. So it's more straightforward from the function flow call perspective. And we decided to go for the SMS text message as a channel of communication because of a couple of reasons. First, even though there's a Wi-Fi on the infotainment, it only allows you to communicate with the infotainment, not to the network. And then, even though there's a feature of syncing with the email, it doesn't work quite right in our test environment. So that's why we decided to resort to SMS text message as our communication channel. So the GUI communicates with its backend GUI, which is called a multimedia user interface over the WebSocket on port 2700. And there's a state machine manager in that MNUI or the backend that keeps track of the state that's happening in the system. And whenever the user or the driver clicks on the screen or touches something, the GUI or the Opera is going to send a couple events to notify, hey, there's such event happening from the user, and then you should update your system. And then the MMUI will keep track of that. And then and the same for like updating the GUI front end from the backend. When the backend receives any events from the lower level servers, which is the Bluetooth in this case, the BDS stands for Bluetooth Developer Studio, but it just in the acronym that's what they call it. So we call it a Bluetooth service. Whenever the backend receives a signal or any events from the lower service, you update that to the GUI over the WebSocket. The GUI backend talks to the lower level Bluetooth servers over dbus, but it doesn't have a direct access to dbus. Instead, there's this message component that acts as an abstraction, and so for the backend GUI, the GUI backend, sorry, yeah. So you expose certain APIs that GUI backend can use, and at the same time, you register a couple of event register callbacks for the message to notify the backend that, hey, there's something happening triggered from the lower level service. And the Bluetooth service, in this case, when it receives the data request from backend over dbus, then its service manager will kick in and then start handling all the corresponding type of the request. In this case, we're more interested in anything that is related to text messages. So here's what happened when the infotainment receives a message. When the Bluetooth receives the message from the pair phone, the service manager gonna kicks in. And then you send a signal over the D-bus, which is gonna trigger the notification manager in the message service. The notification message service, in turn, is gonna trigger the callback to notify the backend GUI that, hey, there's an event happening. And then in this case, it's the SMS notification callback to notify the GUI that, hey, you have a new message. And at the same time, the new message, the content of the new message is going to save in a database, which we'll discuss more in detail later. Then the opera finally gets the notification and prompts the user, hey, you have the new message. So that's it for receiving part. And now here's what's happening when the driver decides to reply or send the SMS text message through the infotainment. When the user says, well, the driver says, hey, I'm going to reply to these messages, the GUI is going to send a couple requests to update, to notify the state machine manager in the GUI backend to send out the text message. The GUI backend then uses the API exposed by the message service to send the data over the D-bus. In this case, the function of interest is the message client save message. And that's important because we'll discuss more about that later on and how we try to do the RAT. And once the Bluetooth service receives the message sent over the Bluetooth D-bus, then you just simply push it out like you expected. So now we know a kind of like generated flow for the text messages. So, and here's what happened when the message is being saved into a database. The database of interest is the SMS.db, and all the data is not encrypted. You can see anything in clear text. There are a couple of tables in there, but the most interesting one are the message and attachment tables. So what are they and how are they different? So data are saved in attachment table as soon as an incoming text message is received. The driver doesn't necessarily have to click on read to see and have the data saved in this table. Whereas for the message table, all the data are saved in there only when the driver says, yes, I want to read a text message. And it's just not that text message. The message service will pull out all the history of the text messages and save that into this table. And so that's a really cool way to see what your teammates are up to and their every dirty little secrets when you're working on the same project. Yeah, so that's how you know like what they're up to. So this is a schema for the attachment table. And then the attachment data is a string. That's actually the content of the text message. And so at this point, we figure out, yeah, you can simply write a C program to monitor this SQLite 3 database. And then based on the string contained there, you can execute the corresponding command. And later on, at the end of this talk, we're going to have a demo. Hopefully that works. Yeah. Seems we have made enough life sacrifice, but who never knows, right? Then we're going to show you how it works in the real life. So that's pretty much for like receiving the command from the remote. But how about sending out? It turns out it's quite a bit of challenge to do so. And so first, the quick and dirty hack is to hack the front end in the JavaScript domain. And after changed and modified a couple of the code in there, we realized that with this series of events, you can send it to the MMUI backend. And then once you send the last one, the send event message, then they can trigger the backend to send out the text message. So now that it's confirmed to work, we kind of move on to modify the original notification handler to hopefully to achieve auto reply or auto respond kind of like mechanism for the RAT. But then as we spend more time with that, we start to notice a couple of limitations with this approach. So first, there's insufficient granular control over the exfiltrated data. All the data we have access to is pretty much only limited in the GUI domain. There's no way to read the arbitrary file of the disk. And in addition, because of the way the GUI works and then the backend works, there's a state machine. You have to send a series of requests to trigger the actual event. And then these events involve the context change. And that results in GUI transition. And therefore, this inevitable effect is going to alert the driver, hey, something's definitely not right. So, yeah. And then, like, you have multiple components for the same RAT, like a C and the JavaScript is just like not really compatible and generic. And so we kind of like don't really favor this approach. But then that being said, there's still some value to this. For example, if you break into the car and then infect the car, there's no way for attackers like us to know the driver of the infected car's number, right? So you can use this approach with JavaScript to send a reply to us, and then like as an attacker, then we know the numbers, and we can start sending the command to the other RAT to start doing some command and control, which is simple in scenario, but it's still not quite what we have in mind, so we decide to move on to other alternatives. And here, Daniel is we have a video to show you like how it works in real life by modifying some, event handlers in the GUI to kind of like prove the concept.
So in this demo, I fight a lot with Ken because he didn't want to show it. He was like, no, man, don't show that. I think it's a lot of value. Even though we didn't use it that much, this is a JavaScript event sending out, okay? What we are seeing here is that we have a trigger to send a JavaScript message out. If we touch the screen on the infotainment in different options, the trigger is not there, right? It's JavaScript driven. So that means we are touching different parts of the screen. That's not touching our trigger, and as long as we go to the trigger is when the message is going to be sent out. So basically, this whole explanation that he said is something very useful for us because we just need, the first time we plug in the USB, we need a message to be sent out to the attacker. This is an easy way to do. So here we go to a specific section, and that section is where we have our trigger. Right there, we were going to click on a specific message, and right when we click the specific message, without clicking send, the JavaScript is going to send the message out to the attacker. So you click there, you see there is the message sent, and the phone in the left or right, wherever it is going to receive the message. So this was the kind of summary of this whole great effort that he did, and that was very important because once we infect the car, we need to send the message out, and then we can control the car. But the first message to get into the car, we don't know the phone number. We need a way for the car to send us the phone number of the guy. And even JavaScript is limited to not exfiltrate information. He can just send us a message out, hard-coded, and we get the phone number of the driver, and then we can start controlling the car.
Thank you, Daniel, for explaining the demo. And yeah, so now our options are limited to WebSocket and the dbus. First, we try the WebSocket, and then we kind of like, maybe not the right approach. And then we start to focus on the dbus. For dbus, we try to tackle that from two different angles. First, we know the message servers expose some of the APIs for the backend to interact with dbus. So we thought it might be a good area to look into. And the other way is to just interface with dbus itself and play with. And so here's what we did. The WebSocket, as expected, is kind of still like, it has similar behavior like the JavaScript. It's just like you send a couple of events to the backend UI, and then the backend GUI, and then you can kind of like shift the change of state in the backend, and then you can from there you can kind of like control that. But still, like inherits all the shortcomings for the JavaScript. But then the only upside is that you can run it in C. All of the dependencies are already on there in infotainment, so you can just have the same components in the same code base, which is pretty good. But we think this is probably a better way to do it. So now we move on to the next approach, the dbus. The first one is leverage the message API. After looking and sniffing around at the messages being sent over the dbus, we figured that, okay, maybe you can try it by looking at the structure. After some digging, we realized that it's kind of like probably not the best approach, but I mean, still it's probably doable because the API is not really meant for the GUI, not for the developers. But desperate time, desperate measures. We decided to give it a shot, see how it happens, right? So from on the right, you'll see the two structures, and then how they represent it in the memory. From there, we can reconstruct the C struct, And then after more reverse engineering, we figure out all the relevant parameters for call list API. But the major hurdle for this approach is that the first argument, which I named it current UTL struct, in memory is actually the struct of size, hex 300 bytes. And in there, you have multiple like mutex objects, callbacks, and more nested struct. After a couple of like segfault in the dbus API implementation, we decided to move on because like, it takes too much time and it's not scalable. And then here is the dbus approach. And it's pretty powerful in the sense like it's easier to write and interact with. And then the best of all is like because all the servers are listening on dbus, and there's no security policy deployed to do the access control. You can send arbitrary, well, not arbitrary, but like as long as you can send any method supported by the Swift servers, just to it and then control the components. And that's really powerful, and it can be done in C and C++. So at that point, we decided to move on with it. And here's a save message, and then the previous one was a get message. So now we know we can kill multiple birds with one stone using dbus. And then we decided to just go for it. And then the better yet, when we were trying to put the libraries into the lib folder, we realized there's some Python debug script, and which led us to believe there's likely some Python environment installed on the infotainment. And then after some trial and errors, we realized that yes, you can actually have a Python interpreter 2.7 running on the infotainment. And then at 5 a.m. in the morning, we are really psyched about this fact. We're like, we can potentially have a RAT in Python script. But then, unfortunately, it's not how live it is. And then Gerardo Ness is going to tell you more about how much fun we have down the road when we're trying to hack the dbus.
So why do we want to use dbus? Well, first of all, because the whole infotainment system is already exposing dozens of different interfaces with really, really interesting functionality. Some of them that really, really caught our eye immediately. Some are listed here. For example, we see that we can interact directly with the Bluetooth pairing operations, GPS operations. We can control the network and the wireless card. We can also interact directly with the phone book from the phone book address from the mobile phone. And also, more interesting, on the bottom, we can deal with SMS operations, just what we wanted for our C2 communication. So just a very brief overview of what dbus is. We have mentioned this along the talk, but dbus is just basically an IPC mechanism heavily used in Linux systems, and this is not the exception. The developers use dbus for almost everything. And well, let's speed up a little bit because we are running out of time. So what do we have in dbus is basically this. We have different objects with identified by unique names and tied to a path that contains properties, methods, and signals that can be used by different endpoints. The methods, they are just like functions in any given language. You can just call a function, even remotely in this case. And you can pass different arguments and receive something back from these methods. Right? For our purposes here, save message and get message are methods really, really interesting. And here's just a very brief description or list of how or what different types dbus supports, the methods in dbus interfaces supports. We have basic types like integers, booleans, strings, and we have container types such as structures and arrays. And we can start playing with them to create more complex structures, nested structures. We can have arrays of structs, struct of arrays of the different basic types. The column on the right is just the different symbols that are used to represent the signature of those methods that we will see in a moment. So yeah, we thought that we had dbus as our best option because of all these different functionalities and how easy it was supposed to be used. But soon we realized that it was not that simple. So our first method of interest, get message, is the one that we are using or the infotainment uses to fetch from the mobile phone the messages that it has received. Here's the XML description for this dboss method. And we see here like the description of the different data structures that it's using. In this case, it's returning as an output. So yeah, we have to deal with this kind of structures if we want to make a call to this method. The other one of interest is a message. It's the one that will allow us to send a message from the infotainment system outside through the mobile phone. Again, this is a description, and we see that, again, they are dealing over and over with these same kind of nasty structures. So there was no way out. We had to start writing code for dealing with this. So suddenly, we were trapped in this very nice cycle of suffering. So how did we proceed there? Like, we started trying different options to see how we could code this part of the RAT. And suddenly, we started trying these two very good tools, dboss send and dboss monitor. These are native tools that are there inside the infotainment system, not only there, like different Linux distributions. And dboss monitor is just like a sniffer for dboss. We can just see all the communications, all the methods and signals that are being called in the boss. Dboss send allows us to register for signals, call methods. They are written using libdboss. The first problem we found there with dboss send is that it doesn't support complex types like the ones we saw previously in the slides. So not that option at that moment for us. So we said, OK, let's go and code our own library on top of libdboss. So how about it can be, right? So when we go to the official documentation, we are welcome with this nice message from the developers. Like, don't even think about it. You are just signing up for a lot of pain. So OK, we will pay attention to that and don't do it, at least not now. So next option, we tried gdboss. It's a different tool that also is really cool because it supports all what we were trying to find, handling complex types. So we had a problem there if we wanted to run this inside the infotainment system. It depends on glib. So we had two options, either compile everything, all the different libraries that glib depends on statically, or compile an old version of glib and with dynamic linking and just throw in those libraries inside the infotainment and hope that it doesn't break. Of course, it was not the case. Once again, we broke it. So we had to continue exploring different options. Next, it comes Rust. Let's give it a try, Rust, right? We can come and try to generate a static binary with that, and we found these bindings for Rust, dboss rs. It has also good support for complex types, but we didn't manage to get a fully static binary. So yeah, let's go for our next option, Go. Also, we found some good bindings for Godboss. So at the end, the same happened. We didn't achieve a fully static binary with Go. However, it was a nice finding because this Go and these bindings allow us to do some very rapid prototyping of different dboss methods that were helpful in order to understand more about the working and the different arguments that the infotainment is using. Later, we tried defeat. It's another very popular tool when dealing with dboss. It's written using Python, JTK, and GI glib. It's very, very powerful and very convenient. We will see a small demo with this. But again, like GTK and GI is not an option to run inside infotainment. But just as Ken mentioned, we had found that before there was a Python interpreter, a Python environment inside the infotainment. So we say, OK, let's try to put a new one, see if it runs. And it ran. We managed to run Python there. The problem is that, again, the bindings for Python didn't work there. It was breaking. Next in the list, libdboss C++, bindings for C++. Excellent support for nested types, just like we were trying to find. And also, by that time, we had these really nice findings. Someone in one of those huge communities of users of these cars had already developed this nice tool chain targeting this very specific version with all the necessary libraries to be able to build binaries for that and running flawlessly. Also, companion of these libraries, there is this tool, DBoss XML to CPP. It's really nice because you can just pass an XML file of description of the different DBoss interface, and it will create boilerplate in C++ for you, just ready to call your library. And at the end, like we say, okay, this is just what we were looking for. But again, the developer of this library thought that nobody was going to ever need more than 16 nested types. It was not our case. We had some of them using up to 19. But we said, okay, like pretty close to what we need. So it's still good support out there, and it requires much less effort from our side. So let's go and do it. Okay, we have DBoss, an API-like functionality for our RAT.
Okay, guys, so let's get ready to the final things so that you can go. I know there is another talk after that. Don't go, please. So how this works. So, okay, so how this works, this whole thing, we start connecting the dots, right? We go the JavaScript, we go the DBoss, we go the Flash, the USB drive, all those components. So the whole thing, how it works is, okay, so the driver is there. You come up with a USB drive that is infected with malware. This guy plugging in because of social engineering. The infotainment got infected. So the RAT is installed, get persistence. Right away, it turns out the bus monitor, as you see, the bus monitor to start sniffing all the traffic going through the phone in the car. And then we need, here is very important thing, guys, that we're going to show. So every time the phone is connected to the infotainment, there is a session. That session is mandatory, and it's going to be changed every time you connect again. If you disconnect your phone and connect, a new session is created. But once we get that session, we can use it with DBoss in order to send all the messages out or all those different SMS-related actions. So it's very important for us to intercept that one. So one of the things that we do is we use the test app server in order to reset the phone so that even the driver is with the phone, we send a reset, and then it goes again, generates a new session key, we get it that, and then we start proceeding with our attack. So that's the way it is planned. And then once we get that session key, then Salinas RAT is going to send an SMS message through JavaScript through the attacker, so that now the attacker knows that this specific car is infected. He might be in China, he just received a message, and he knows now that the RAT is inside a car, right? It's all SMS. So then after that, what we did is now we're going to start sending messages to the car. So the RAT is able to understand the messages. So basically, when we send an SMS message, it has a prefix. So when the RAT receives the messages, it is monitoring those messages through DB's monitor. It will say, oh, this message comes with a prefix that I know is from the attacker. Then it will proceed and execute our commands. If it says it's not the prefix that I'm expecting, it just let it go, and it just as it is as usual. So that's the way we communicate with the RAT, and we're going to show you that in a second. Okay, so let's do the research. Let me just put this thing here. If it doesn't work, guys, don't worry. The demos never work. Don't feel bad, please. Okay, so let's try. My friend, can you hold my microphone close to my mouth in the whole demo? Closer. Yeah. No, my friend. Yes, like this, my friend. Yeah. Like the microphone is kissing me, like that, my friend. I love it, man. Is my mom looking at this video? Hopefully not. Okay, guys. So see, we have here the screen. Can you see the screen? Okay, let me just put a little bit. Yeah. Okay. So in the right side, we have DBoss monitor. We are connected to the infotainment through Wi-Fi to do this demo. Then we're going to do a full SMS demo also. So we run DBoss monitor on this guy. I just need to connect to the infotainment. Okay, and let me just copy-paste this guy. So we're going to run DBoss monitor so that we can start monitoring all the messages coming, right? So DBoss monitor is ready right there. So what we're doing here is that we know that that specific folder list event is being called every time the phone connects to the infotainment. That specific event is triggered. So as soon as it's triggered, we're going to catch the specific session. So let's go here in the other side. So at the bottom, we have the test observer. You remember the one that we found in the firmware? So at the bottom, we have the test observer running, and at the top, we have the client. So what I'm going to do is just so that you guys kind of see how it works, we're going to send a message that we understood while doing this specific reversing, that it says, hey, give me all the different phones paired to this infotainment. That means the phone is paired just one time, right? You don't pair all the time. So this is telling us that there are 2 MAC addresses, which means this infotainment at least has 2 phones paired in the long life of this guy. But now we want to know which is the one that is actually enabled at this point, which means which is the one that the driver is using, which is the one active. That's not pair, that is called connected phone in the infotainment language, okay? So we do again the same command, but this time we say 5.18, and it says there is one device connected. That one is my phone. So I'm running this, in this whole scenario, I am the guy connected to the infotainment, so that's my MAC address. With that information, what we're going to do right now is we're going to disconnect this guy from the infotainment so that it can reissue a session for us, and in the right side, we're going to see how it is triggered, okay? So I'm going to say here, again, it's another, obviously, a different kind of commands so that we can trigger that. So when I click here, in the right side, just take a look at the dboss. I click enter. This guy starts disconnecting the phone from the infotainment, reissue, connecting it back, and see in the right side DB's monitor. DB's monitor is going to eventually get here the session. So we got here, this is the specific timestamp. This is the context ID and the connection ID. These 2 guys is mandatory for us if we really want to intercept a message, okay? So can you switch to the camera a little bit? I want to show you something. Full screen or, yeah. So what I want to show you guys is now, closer, my friend, closer, yeah, thank you. Okay, what I show you guys now is that, look at the infotainment at the top where it says import success. I'm going to issue the same command that you see here, and it's going to trigger a phone disconnect and phone connect. Let's check it out. Phone disconnected, and then that's going to take some seconds, and then it says phone connected, and that's exactly what I show you behind the scenes, but that's the way it looks in the phone. Okay? Now the phone is connected, but we now have that session, and with that session, we're going to proceed to steal messages from this poor guy that is connected to that car. Okay? So that's going to be shown by Gerardo. Okay, so while he's gonna be ready to do that next step, the scenario that we're gonna be playing here is that I am the guy connected to that phone. Keep in mind that this all happening when you are driving, right? Our shot on this whole thing is when the car is being moved. So I am the guy that is connected to the phone. Then another friend of mine, which is gonna be Gerardo or whoever. What happened, man? Okay. So this is my friend, right? This friend is going to send a message to the to me, but I'm driving. That message is going to be received into the infotainment, and then after that, since it's infected with the rat, Gerardo is going to get that message, get many others, and send it out to the attacker. The attacker in this case is Ken, and so he's going to receive that message. So are you ready? Okay, I keep talking, man. Yeah, keep talking? Okay. So as you know, guys, so this is very interesting talk, as you can see. So we're going to send the message out. Okay. So one thing important here. You are going to see that dboss, we're going to steal just 4 messages, but it's just about to change the parameter, right? You can say 4, or you can say 200 messages. So at the end of the day, at this point, we can just send out everything we need.
Can we have the 2 of them? So here what we are going to show you is like basically how it's working under the hood. What's the RAT supposed to do, like when we don't see, right, the operation. So as Daniel explained, how we achieve that reissuing the connection or reinforcing the connection of the mobile to get the current connection and context ID, so we can piggyback on top of that connection. So those are the values that we already obtained in the previous demo. And this is the tool I mentioned earlier, defeat. So here we see how we are going to abuse those two methods in order to exfiltrate those messages, to steal them and send them out to the attacker. So actually the first one that we are going to use is get message list info that will allow us to fetch from the phone the latest messages that the phone has received. So here we are going to send a new message from some random person to the driver's phone.
So this starts everything, right? He's going to steal the messages, but we want to send also another one, right? So that is kind of full process. So I want to send a message. I'm the friend of Daniel, so that message is going to be sent. The message is going to be popping up in the screen of the infotainment in a second. You see the message is there. It pops up there. So now, at this point, as you know, the session is intercepted, and now Gerardo is going to try to steal those messages.
Sorry about that.
You're going to see some phones there. Of course, those are not our phones, of course, right? Those are testing phones, so it doesn't matter, you can call them. I think Ken's is his phone, but don't call him, please.
Just 1 sec. Copy the wrong one.
Can you talk while doing?
No, I can't.
Okay, so should I talk? Yeah, okay.
Yes, sir. No, wait.
So let me explain what he's trying to do. So at this point, we got the session. What he's trying to do now is use that session, call the boss, get the message from the phone, directly from the infotainment, from my phone, and then send it out. But that he's building, that whole list that you see there is passing at the beginning the session, context ID, connection ID, and calling this specific line into the tool. If you want, we can resend it so the boss can catch the session again, if you want.
All right.
Is that session live?
No, probably it's not.
No, can you switch to, I have also the session is in my capture. You know what I mean?
No, it's
So he's using the wrong sessions. That's why he's not getting anything connected through the DBoss. So if it doesn't work, we will just catch another session, reconnect the phone, and get the right sessions. Let's see. You miss a parenthesis at the end. But I think you miss a parenthesis. Okay, let me do something. No, we cannot because you have the same laptop.
Okay, there. So what we got back from that method is the last 4 messages. Here we are indicating the number of messages we want to retrieve from the phone. So we got 4. Like probably it's not very easy to read them right now. So we're just gonna use this other Python tool we have here to be able to read them easily. Close this. Okay, so this tool is basically just parsing that output into something more readable, just so we can appreciate what's going on. And we have the 4 instances that we asked for with the timestamp, the sender number, the sender name, and the text contents, right? So in this moment, we already stole the messages from the phone without the user knowing about this. So now it's just a matter of sending. And I'm using the other method call we discussed, save message. In this case, we are gonna send these messages to Ken's phone. Like he's gonna play the role of the attacker.
The phone that is here, that's Ken's phone. We put it there so that you can see when he receives it.
So it's going out. Takes a while, then it's there.
And you see that he got the messages. So he got 4 messages out, but he can get 200 messages out. So
this is just one example of what we can do by abusing these DBoss methods. Like, thank you. Like, there are 1 or 2 short ones that we want to show you, like from. Like
yeah,
we have the time.
So just pretty much it. Let me just send a couple of messages just to finish this demo. So the first message is more, the first example is more distracting driving. So what we're gonna send a message to this guy, and then we're gonna just start, turning off and on the display so that it's just distracting driving. So let's do that. So he's gonna send a message with a specific prefix, with a specific ID. So the RAT has specific IDs in order to execute the messages. Did you send it?
The message is out. There.
Okay, the message is there. We're showing the message, but obviously this can be hidden, right? And then after the message is there, these guys just start popping up, right? And then it's just a way for you to see how we interact with this guy. This is also DBoss thing. It is the latest tool that he identified at the end is working with this implementation. So now, don't send it yet.
Mm-hmm.
Okay, thank you. So now, the last one is just to kill this guy, reboot it. We need to put something there because we don't want to see it. Something there, but anyways. So we're going to reboot it. You know, my friend, take it out, man. Let's get sued. Don't care, my friend. Let's do it, man. Okay, no, you're just kidding. So we're going to send the message out. This guy is going to be rebooted, and it's going to get into a state, the state that we got 3 months ago, so that it doesn't recover anymore. And this just, you need to take it to a dealership or get UART in order to fix it. So sending the message out.
The message is gone.
It takes some time. Just a couple of 10 minutes, man. So don't worry. It's gonna. Okay, it's there. It kills the infotainment. Now it's rebooting the system. That's like an eagle. You know eagle? You know eagle, right? Okay. So then the infotainment just goes into a loop. It will never boot up again, and that's pretty much it. So you will need to take it to a dealership at this point. Okay, after the math, since it's your turn, right?
Okay.
Yeah, after the math.
So unfortunately.
Okay, great.
Yeah.
We are done.
Okay.
No, just one thing. I just want to thank to my wife, Ciris, at the end. Yeah, thanks to my wife for this thing. So he allowed us to be here with these guys. I hate them all. But anyways, Thank you.
Yeah, please thank the speaker and his wife again.